Yes. Yes. May I wish you very good morning to every UPSC aspirants. This is the presentation from Arivu Academy located at Bengaluru, Chandra Layout. Today we are discussing about CSAT syllabus exclusively. What the syllabus content, what we need to learn, what are the topics are generally required to crack the CSAT examination. All of us know very well, there are 2/3 of questions will come from aptitude and reasoning. 1/3 of the questions are passages. Now 2/3 of 80 questions is what? 52 to 53 questions. Let us say that is. But out of 52 to 53 questions and 20 questions, it means from ranging from 18 to 22 questions are happening from number system. So what is that number system? Leaving the 20 questions, another 30 questions, 4 to 5 will happen from puzzles related questions. And another 7 to 8 questions will come from reasoning, like coding, decoding, number series, alphabet series, like missing character, mathematical operation, and syllogism, like that. Directions related, coding, decoding, like. Another 15 to 16 questions will come from aptitude, that is time, distance, speed, time and work, averages, fractions, prime numbers, all the. But 20 questions will just happen from number system, where one can solve, everybody can solve 14, 15 questions easily without taking much time. Let us see what the syllabus is. And the syllabus has been designed in such a way that is, it enables every aspirant to learn more quickly and where to concentrate, how to practice. And whenever you have a doubt, that is, you can come up, you can go to some material, you can find from your mentor or your faculty at your coaching center and so on. Now let us see what exactly is out. And see now what we need to know here, squaring of numbers. But this is the lesson plan. Normally we do this syllabus accordingly in our class, regular classes. Now let us see that is squaring of numbers. Squaring of numbers, in the sense we need to know, every aspirant needs to know that one should remind, that is 1 square to 25 square, up to that. Questions are designed there. 1 square to 25 square. You need to by heart, actually, that is, okay? We should not take much time. If you do not this, if you don't remind this, you are consuming a lot of time at the cost of another question. So that should not happen, because many questions are framing from here, 1 square to 25 square. 1 square is 1, 2 square is 4, 3 square is 9, and so on till 25 square. Okay. Next, cubes. 1 cube to 11 cube is required. Now questions are happening number series or mathematical operations in many areas, and divisibility rule, all these things. Now again, apart from this, plus you need to know 21 cube. This is 9261, because this is appreciation, depreciation, population growth, compound interest. The same formula will happen, that is. So that is a squaring of number, so much it is required. Fine. Again, I said that is what are the ways of solving this. If you see the question number after 26 square, 27 square, 28 square, 95 square, how to do that? So this is only one way, is what arithmetic process we can do. And another is what a plus b whole square or a minus b whole square, and summing of consecutive numbers, quick multiplication method. Let us see the B and C. Mostly it is known to many number of people. C, you may not be knowing that C, and let us see how it can be done. I just give some examples of it. Now you can see a plus b whole square. For example, see, like 31 square. 31 square. What is 31 square? It can be written a plus b whole square. This can be written as 30 plus 1 whole square. So a plus b whole square. This is what? A plus b whole square. This is a, this is b. This is 30 square plus 30. What is a plus b whole square formula is what? I'll write a plus b whole square. A plus B whole square formula, A square plus 2AB plus B square. This is 30 can be treated as A, 30 square plus 2AB, 2 into 30 into 1 plus B square, that's B, 1 square. So 30 square is what? 30 square is 900 plus 2 into 30, 60. 60 into 160 plus 1, it is 961. So this is the answer. This is A plus B whole square, or sometimes A minus B whole square also. So this is one. Now, if it is the like that, like 29 square, 29 square, let us say 29 square, it means this is very close to 30. So 30 minus 1, 30 minus 1 whole square, or so 20 plus 9 whole square. This is A plus B whole square, this is A minus B whole square, same formula, that is okay, right. Okay, now we can see, and summing up consecutive numbers. Summing up consecutive numbers. This is another easiest method like that. But say for example, now 11 square. Assuming that is, we know 11 square. 11 square is what? 121. Right. Based on this method, how it can be done? This is the nearest to round figure is 10. 10 square. 10 square. Okay. 10 square. This is 10 square is what? 100. And 11 square is equals to 10 square plus 10 plus 11. It means 10 square is 100 plus 10 plus 11. 21. So 121. So like that. It means you can see other way also you can hear. Now for example you can say 1 square. What is 2 square? 2 square is equals to what? 1 square plus 1 plus 2. 3 square. For your convenience sake I am just showing some 4, 5. And 3 square is equals to what? 2 square plus 2 plus 3, and 4 square is what? 3 square plus 3 plus 4, 3 plus 4. What is 5 square? 4 square plus 4 plus 5. So like that. Say for example 16 plus 4 plus 5, it means so 25. 5 square 25, all of us know very well. This is the summing of the consecutive. When this is helpful for us is, that is most important. Say for example, you wanted to know 91 square. 91 square. So 91 square is means what? You can take the previous number 90 square plus 90 plus 91. 90 square, 9 square is what? 81. There is 1 0 means you can keep 2 zeros here. 90 plus 91 is 181. It means 8,281. So this is how it's helpful for this. Because we need to know these things. We can, with a lesser time, we can see the maximum productivity. Now fine. Okay, quick multiplication method. What is the quick multiplication method? That is, normally we can say for example, like 12 square. Let us take the easier numbers, 12 square. How to make 12 square here? It means 12 into 10 plus 2, it can be written. So 12 into 10, 120, plus 12 into 2, 24. So this is 144. This is the quickest number, like that. Even if you say bigger numbers also, you can take like that. Say for example 125 square. We wanted to know 125 square. How 125 square will be written? Because we don't remember all these numbers. You can take 125 multiplied by, you can split into 3 parts, 100 plus 20 plus 5, like that. It means 125 into 1, 125 only. How many zeros are here? 2 zeros plus, and 125 into 2, 250, 1 0, right? Right, you can take plus 125 into 5, So like 500, 625. You can take like this. So this is 500, 1000, 1000, 625. 3 plus 5. This is the answer. You can take. Okay. So this is the one pattern. Okay. Now let us see that arithmetic process. What the arithmetic process is like? It is a basic important portion of the Vedic mathematics. Let us see, for example, here. Now let us take 12 square. This is the 12 square. So you can say 12 square means how do we can do that is like same a plus b whole square you can take, and right you can calculate from the right hand side, from right to left. Normally we do this process from left to right. Here you can do from right to left. Let us say right to left. 2 square 4. 2ab 2 into 1 2. 2 into 2 4. Like 1 square 144. Very clear that is. Say for example like 23 square. Then how we can do that is right hand up. 3 square. 3 square is what? 9. 3 into 2 6. Double it. 6 into 2 12. Take one digit here, one carry. And 2 square is 4. 4 plus 1 5. See, that's why arithmetic process I did. Mentally you can finish up this job without taking pencil and paper. Right. Yes, now let us come to the prime numbers. Prime numbers is a very important concept. Paper examiners always see, you have to see that right. Prime numbers. Prime numbers is a very important topic in the number system. You will have at least 3 to 4 questions will come from prime numbers related. Whether number series you can see, whether the mathematical operations you can see, whether the divisibility rule or LCM and SCF factors, in many ways you can see also. Sometimes in the statements also you can see data sufficiency also. Prime numbers you must know, but one is to every aspirant must know the prime numbers in the first 100 natural numbers. How many prime numbers you can see from 1 to 100? We need to know, every aspirant needs to know the prime numbers. What are the prime numbers will happen in the first 100 numbers? Like that is very important. Next, because the questions also will happen straight away like that. What is the prime number definition? Definition he needs to know that is. Here you can see definition. What is the definition for prime number? People immediately say, many people say that is 1 is a prime number. 1 is not a prime number. Prime numbers always starts from 2, right? You can say why? Because it's like that. Prime number definition is what? And people say, some people say 2 is the first prime number. But why means they do not have any answer. Why? Because definition we need to know. For anything you can say definition we need to know. Every aspirant needs to know especially the definitions. When the definition is known, you can answer any type of questions also. Statement type of data sufficiency questions. You can answer the question, you can find the options, you can shortlist the options, you can do many forms and a very faster way. Right. Prime number secant, that is again definition is what? A number which can be divisible by 2 distinct factors. Say for example 1. 1 why you cannot be prime 1 by itself and 1. But 1 and 1 are not the same factors. It's not a distinct factor. There must be 2 distinct factors. So 1 is not a prime number. Say for example 2. 2 can be divisible by itself and 1. There are 2 factors. So this is the prime number. And say for example 4. 4 can be divisible by itself, 1 and 2. There are 3 factors. So 4 cannot be a prime number. Prime number, the number which can be divisible by 2 distinct factors according to the definition is known as a prime number. That is a thing. Okay. Anyway, now let us see that is a co-prime numbers. Again, you can see co-prime numbers, very, very important. It's a backbone for the number system. You can check that is which number can be divisible by which number. You will have at least one question easily will happen from co-prime numbers. Even finding the SCF, finding the numbers, sum of the numbers, LCM is given, SCF is given. They ask you that is, what is the sum of the numbers? Then you need the co-prime numbers. And some questions are asked like that, which number can be divisible by which number? Then again you need to know the co-prime numbers. For example, you can see, even a recent paper also you can see, which exam which was held on 24th of May also. You can say there was a one question related to this only. But questions are not asked directly, but we need to know that is. And see now, some numbers will be there, like A, B, C, D, number will be there. A number will be there, which is divisible by 88. So 88 you cannot do. It takes a very lengthy process. That's why you need to know the co-prime numbers. What are the co-prime numbers? 8 and 11. 8 and 11. 8 and 11 are the co-prime. If the number is divisible by 8 and 11 is known as a, then the number can be divisible by 11. What is 8 and 11? Because 11 is, both the numbers are divisible by only 1. So it is a co-prime numbers. Say for example, 2 and 3 is a co-prime numbers. And 4 and 5, 4 and 7, 4 and 9, like 4 and 11. All these numbers are divisible by only 1. Say for example, if 7 and 14, both numbers are divisible by 7. 7 and 1. Highest factor is what? 7. So this SCF is 7 here. These are not the co-prime numbers. If the numbers only should be divisible, both the numbers only should be divisible by 1, then it is known as a co-prime numbers. This is very essential for finding the number which can be divisible by which number, like that. Say for example, say that is 30, for example 2. 2 can be divisible by itself, okay, right? And 3 is a prime number. We don't need a co-prime numbers for that. 4 is a composite number, and 5 is a prime number. 6, see for example 6, what are the 6? You can take 6 divisible by, which are the numbers? 2 and 3. See, 2 and 3 is the co-prime numbers. If the number is divisible by 2 as well as 3, the number can be divisible by 6. And questions are asked indirect way also, but we must be knowing the co-prime number concept. 1 or 2 questions, definitely it is possible. Without these concepts, question paper cannot be designed. You need to know that is, right? Now let us see the twin prime numbers. We discussed this. And what are the twin prime numbers is what? The consecutive prime number, difference must be 2. Say for example, what is the first prime number? 2. 3. You can say 2, 3, 5, and 7, 11, 13, like that. And see the difference between 2, 3 and 5, difference is 2. This is 3 and 5 is the twin prime numbers, 1. And 5 and 7, the difference, both are prime numbers, difference is 2, consecutive prime numbers. This is the twin prime numbers. Again you can see 11 and 13. 11 and 13 is the twin prime numbers, that is. But how many prime, question may be asked like that, how many co-primes are, twin primes are possible in the first 100 natural number? What is 100 natural numbers? Natural numbers are always starts from 1. The difference between the natural number and whole number is 0. If we say what is the first 25 natural numbers, writing numbers from 1 to 25. And what is the first 100 natural numbers? Is writing from 1 to 100, right? So this is the, but question is can be is, and we have to know that is number of prime numbers in the first 100 natural numbers. How many co-prime numbers in the first 100 natural numbers? Beyond 100 question, the people may not go, that is. And how many twin primes are possible in the first 100 natural numbers? If you keep writing, there will be 8. Again, prime triplets. What is a prime triplet? Is what? Is a 3 item. Triplet, like prime triplets. What is the triplet? Prime triplets. All the same. Prime 1, P2. Let us P3. So this is P. If you say, for example, like 3 plus 4, 3 plus 2, and plus 4, like that. Like that's a prime triplets you can take. And I just say, I'll write a prime triplet. What is a prime triplets formula is what? This is, you can take A1, A2, A3. All the prime numbers only. Prime number. This is the prime number. And this is the plus 2 and plus. P1, comma, P1 plus 2, P1 plus 4. So this is the prime triplets. How many prime triplets are possible in the first 100 natural numbers? There are 8, but you have to see that. Okay. In the class, we can discuss all these things in detail form. Only I'm talking about what is the syllabus one aspirant needs to know. Right. Now let us see. Now integers. Again, integers you will have need. You see the 5 to 6 questions, they talk about the word integers like that. What are the integers? See the number line here. See, I have mentioned here number line. What is the number line? This is the number line. This is 0. This is -1, -2, -3, +1, +2, +3. See, to the left of 0 is all minus values, -1, -2, -3, -4, -5, and n, -n. And from to the right of 0, plus values, +1, +2, +3, +4, +5. So this is integer. This is integer. So this is positive integers. Positive integer. And this is negative integer. Negative integer. And almost year after every alternate year, you will see one question straight away. Question is being asked. In the I think 2 years ago, a question was asked in such a way in CSAT. And I'm talking about only CSAT here. Okay, what is the smallest negative, non-negative integer like that? Integers are what? So positive integers, negative integers. 0 is a integer. That's all. 0 cannot be treated as either plus or minus. Okay. Now that is the number line. And positive integers are what? +1, +2, +3, +4, and so on. Negative integers are what? -1, -2, -3, -4. Integers is only 0. That is number line. This is a number line. So if you forget this is, you can write the number line. Okay. Questions are asked sometime like that. What is the difference between -3 to +3? It means definitely will happen what? 6 like that. Okay. Yes. Anyway, and we see that is next natural numbers. Again, see that natural numbers is very important. It plays a vital role in number system like that. What are the natural numbers we discussed so far? Is what? Natural numbers are from 1, 2, 3, and so on. It goes on. First 10 natural numbers is what? From 1 to 10. First 25 natural numbers 1 to 25, and so on. It keep going like that. Okay. Now, see the wording is very important here. The people are where we are finding difficulty is people know English, they are unable to understand the terminology. You need to understand the terminology here. Natural numbers, everybody knows now. Let's talk about the consecutive natural numbers. Consecutive in the means continuously without any break. For example, consecutive natural numbers like 1, 2, 3, 4, 5 consecutive natural numbers, and 10, 11, 12, 13 is a consecutive natural numbers. And consecutive odd numbers. What are the consecutive odd numbers? Consecutive in the sense what? Continuously without any break at all. Consecutive odd numbers are what? 1, 3, 5, 7. This is the consecutive odd numbers. If you write like that 1, 3, 5, and 11, but all are odd numbers, but this is not consecutive odd numbers. This is consecutive odd numbers. That is a thing. And consecutive even numbers. See, consecutive even numbers is what? Even numbers are what? 2, 4, 6, 8, 10, 12, and so on. That is. So I'll keep the ellipse. Ellipse means what? Happening continuously. Right. And these are the consecutive numbers. If you write even 2, 4, and 12, all three are even numbers, but it's not a consecutive even numbers. That's where the discuss. Because if you see any question, you take any paper of your choice in a CSAT paper from 2011 to now, even recent paper which was held last month on 24th of May. That's for Sunday. No? You can see that This terminology is more important. That's why in our classes, we discussed a lot about the terminology. If you know the terminology, if you can understand the terminology, you can read the question, you can understand the question faster way. You will not go panic. You will be feeling very comfortable in answering the question. You may be knowing to answer the question. The problem people, aspirants are finding very difficult to understand the terminology. This is a very simple terminology. That's why in the syllabus, I have mentioned about the words which are used in mathematics, or you can call arithmetic, or you can call CSAT, whatever the way you want. Right. So consecutive natural numbers, consecutive odd numbers, consecutive even numbers, and first consecutive numbers. First in the sense what? Happening from first. Like, what is the first consecutive number? First consecutive even numbers. First consecutive odd numbers. It's a very simple one. Okay, questions and all can be seen in the upcoming classes. Now we can see right. Now, so multiples of natural numbers. Multiples of natural numbers are what? Like a multiplication, like a table. Sum and average of natural numbers. We have to find the sum. Questions are happening here. Questions always, you can see the number of questions will come. 4 to 5 questions will come from this particular topic only. And sum of first consecutive natural numbers, and see. And say, for example, you can say, what is the sum of the first 10 natural numbers? You cannot write 1 plus 2 plus 3 plus 4. For first number from the beginning and first number from the last. By 2, you get the average. Average into number of term, you will get the sum. Like that. What is the sum of the first 100 natural numbers? So 1, 2, 3, 4, and you will write up to. What is the sum of the numbers? First number from the beginning and first number from the last. Divided by 2, you get average. So average into number of observations, you will get the sum. So that is what. Even n into n plus 1 by 2, we studied our school days, right? Okay, sum of first natural number, this is right. Now we can see, and face value or place value. Face value is what? Any number. For example, see if I write the 1, 2, 3, 4, 5. Like, what is the face value of 3? Is 3 only. Place value of 3 is what? 300. The sum of face value and place value of 3 is what? 300 plus 3 is what? 303. Sometimes this also difference of place value and 297. So same thing. Multiplication also may be asked, that is okay. Right. And mean and middle term relationship. Mean means what? Middle term is an average like that. Middle term is what? Average like that, you can say. And next digit numbers. Okay. So this is a very, you will see that at least 1 or 2, 3 questions from this particular area like that. If you see any question paper like that, sum of the digits of a number, sum of the digits of a number. For example, see a number, let us take a number 10. What is the sum of the digits? 1 plus 0. It means 1. So 11. So 1 plus 1 is 2. And 12. So 1 plus 2 is 3. Like that. So 3-digit number. What is the sum of the digits of the largest 3-digit number? Largest 3-digit number is what? 999. Sum of the digits. It means 9 plus 9 plus 9. So 27. It's like that. Okay. But we need to understand the terminology here. What I'm trying to say is what? Terminology. Sum of the digits of a number. Okay. Sum of n-digit numbers. Sum of n-digit number. It means question may be asked like that. How many 2-digit numbers are there? How many 3-digit numbers are there? How many 5-digit numbers are there? Say for example, 1-digit numbers are what? 9. 2-digit numbers are 90. 3-digit numbers are 900. 4-digit numbers are 9,000. 5-digit numbers are 90,000. 6-digit numbers are what? 900,000, and so on like that. Okay. Yes. And questions are where questions are asked here, especially 5-6 questions will happen from here. And sum and average of n-digit numbers. Okay. Already I discussed that is in the previous topic. Okay. Counting of digits in natural numbers. Say for example, if you write numbers from 1 to 150, how many digits are possible like that? Okay. Now we can see composite number. What is the definition of a composite number? Composite definition, prime number, non-prime numbers are always composite number. What is the definition of a composite number? Say for example, it can be a number which can be divisible by more than 2 factors. Only 2 factors is the prime number. More than 2 factors are composite number. Say for example, 4. This can be divisible by 4, 2, 1. It means this is the composite number. Let us take 6 by itself, 1, 2, 3. There are 4 factors are there. So it is a composite number. Okay. A number which can be divisible by more than 2 factors is known as a composite number. A number which can be divisible by 2 distinct factors is known as prime number. That is a factor and sum of composite numbers. Okay. Yes. Now we can see the factors. What are factors? Again, factor is very essential here. Again, see, all these questions will happen from natural numbers, prime numbers, and co-prime numbers, factors. These questions will happen because sometimes the 2-3 items will be clubbed into making one single question. Definition in mathematics. What is the factor? Factor means what? Definition again. What is the need to definition? A number, a divisor, which can divide the number completely is known as a factor. Say for example, like 7. 7 can be divisible by itself and 1. So these 7 and 1 are the 2 factors for this. And see 6. 6 can be divisible by itself. 1, 2, 3. There are 4 factors. So these are 4 factors. A divisor which can divide the number completely is known as a factor. Say for example, like let us take 11. 11 divisible by 2. Is it possible? No, because 2 is not the factor. If you take 1, is not the factor. 1, yes, it is a factor. 11, it is a factor. If you take 11 divisible by 3, no, you will have the remainder. So 3 is not the factor. It's like that. It means what is the definition for this? A divisor which can divide the number completely is known as a factor. Right. We can discuss in detail in the upcoming classes, upcoming regular classes. Okay. Right. Uniqueness of numbers. Again, what is the uniqueness of numbers here? Uniqueness of numbers. See the 1, 2, 3, 9, 11, 99, 1001. So always you will see the questions are happening from related to 11, 9 and 101, 1001. I'll give you some basic, some simple examples you can see. You will see one question, either way you can see one question will happen from this. For example, you can see here the uniqueness of numbers and 9. 9 means again big list is there for that. Always you will see two questions will happen from related to divisibility by 9 and interchanging the digits of the two-digit numbers. Say for example, now let us take some number like 23. 23 multiplied by 101 is what? 23 and 23. 23 gets repeated. This is the properties of numbers. You can take any two-digit number. 39 into 101. It means 39 and 39. And 91 into 101 means 91, 91. Like that. Same if we take three digits, like 123 multiplied by 1001, it means 123, 123. This number gets repeated. And take any of your choice. 479, let us take, multiplied by 1001, this number gets repeated. These are the properties of numbers. You can take any of your numbers also. 1, 2, 3, 4-digit number multiplied by 10,001, it means 1, 2, 3, 4, 1, 2, 3, 4. These are the properties of numbers because always questions are happening from this related topic. This is okay. And 1001. Why? Because 1001 already we explained here like that. And 1001 is equals to 7 into 11 into 13. This is a fixed property. He will have every alternative with a direct question. One question will happen directly here. Okay. Anyway, other things can be discussed in the upcoming regular classes. Right. Now we can see fractions and its properties. What are the fractions? Say for example, proper fraction, improper fraction and mixed fraction. And there are certain properties that can be discussed. Okay. And for example, you can take any proper fraction is less than 1. Say for example, 11 by 99. 11 by 99 is a proper fraction, is always lesser than 1. When numerator is lesser than the denominator, is always lesser than 1. It means you can take 1 minus 1199. What is the remaining fraction difference? Only you have to see that is 88 by 99. Say for example, 1 minus 1 by 4, everybody knows this is. It means 3 by 4. Difference between the numerator and denominator. And see 1 minus 7 by 9. What is the difference between the numerator and denominator? 2. And denominator can be retained here. And like that. So this is the fractions we can take. And result of even odd numbers. Result of even see the sum of odd numbers and sum of even numbers and product of even numbers and product of odd numbers. Every paper you will see 1 or 2 questions are happening here. Say for example, like 2 plus 4 plus 6 is always even number. Sum of n even numbers always an even. These are properties. And again see odd numbers, let us take 1 plus 3 is 4. Sum of 2 odd numbers is always even number. And 1 plus 5, 6. Sum of 2 odd numbers is equals to even number. 3 plus 5, see 8. Even there is a one question in the very recent exam, like that. That we need to know. Sum of odd numbers, sum of even numbers, and product of odd numbers, product of even numbers. That's you will see the 1-2 question. You don't need time at all. You need not to consume time at all. Just if you know this, you can go ahead with the shortlisting the options given. Right. And next, I think we'll go to the next page. Right. Now you can see sum of terms of even numbers, product of n terms of odd numbers. I have given in detail that product of n terms of even numbers, unit digit and product of consecutive numbers, odd numbers, even numbers. If you know all these, if you practice, even if you forget also, if you go by the syllabus, what is given lesson plan, that is, you can also immediately can come to the practicing wherever you don't know. Right. Now let us see about the item number 13, more of exam point of view. These are all exam point. A 3-digit number found by repeating 1-digit number thrice. It means, see the language, how the language is being used. A 3-digit number. A 3-digit number. Right. You should write like that. A 3-digit number, put 3 into X mark. Formed by repeating 1-digit number thrice. Maybe 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, and so on. Okay. See the language, how to read that word, group of words. A 3-digit number. When you say the 3-digit number, you have to write immediately. 3-digit number means what you should do? You have to put 3 into marks immediately. Because we do not know which is the 3-digit number. Immediately, you should not waste the time. You should not repeat the question once again, that is. You can avoid the reading the question again and again. A 3-digit number. Formed by repeating 1-digit number. Formed by repeating 1-digit number thrice. Maybe here you can take 1, 1, 1 or 2, 2, 2 or 3, 3, 3 and so on. Always divisible by 111. Always divisible by 111. Always these numbers are divisible by 111 like this. Like that is a property. Also by 3 and 37, because 111 is equals to 3 into 37. Like that's how what I said. Even 1001 is equals to 7 into 11 into 13. So this is you will see the questions are happening here. Okay, because why? Because questions are happening. These are the properties of numbers. Properties of numbers. Right. Now we can see a 4-digit number found by repeating 2-digit number always divisible by 101. Again, this is the directly or indirectly. A 4-digit number, repeating a 2-digit number. Let us take 2525. Always divisible by 101. Okay, just like that. Say for example 36, always divisible by 101. 98, always divisible by 101. Okay. The number 0 is surrounded. Okay. Now we can see this area is what is this area, because see now we can take 11 square is what? 121. Every aspirant know this. And 111 square, definitely we go to calci. But calci is not allowed to the examination hall, but calci is not required. Right. This is 11, 121. This is 1, 2, 3, 2, 1. You can see. What is the observation here? You can see this is square. It means how many digits are here? There are 4. It means 1, 2, 3, 4 and backward 3, 2, 1. See like that. 5. It means how many are there? 5 ones are there. 1, 2, 3, 4, 5, 4, 3, 2, 1. It goes on like that. These are properties of numbers. And the same way, you can also see for even 0 also. Say 11 square is what? 101. We know 101 whole square is what? 0 is surrounded. No? 1, 2, 1, 0 you can insert. If it is like that, 1001 whole square what? 1, 2, 0, 2, 2, 0, 1. It goes on like that. Okay? Yes. In detail, it can be discussed in the upcoming regular classes. Right. And now we'll move on to the next. Yes. Now we can take, there are many items, properties I have mentioned in the syllabus. Okay. Now n to the power of p minus n in multiples of p always. I'll give one example of this. N to the power of p. Natural n means what? Is a natural number. Let us take. And p is a prime number. Prime number, even you can take 2 minus n. n we have taken L, always is a multiples of prime number, multiples of p into x like that. So this is the 4 minus 2. So 2 you will get is a 2 into 1 you will get. Like that, retake that is right. And 15, 9 into 10 to the power of 9 minus 1. So it means 1 digit number, 2 digit number, 3 digit numbers. You can check like that. Already I have discussed this. But formula I have mentioned here. Now you can see rule of divisibility. What is the divisibility rule? This is essential part again. The part and parcel of the aptitude as well as the number system. And aptitude also it is required very much. This is which number can be divisible, which number like. For example, you can see and any like divisibility by 2, by 3, by 4, by 5, by 6, by 7, by 8, by 9, by 10, by 11 like this. What is a rule of divisibility? If the last digit is 0 or even, it can be divisible by 2. So for example, see, last digit is 0. Any number you can take, last digit is 0 or even, always divisible by 2. If there are 2 zeros and always divisible by 4. If the last 3 digits are 3 zeros, always divisible by 8. So the same rule. And divisible by 3, the sum of the digits is divisible by 3, the whole number can be divisible by 3. For example, you can take 1, 2, 3 is divisible by 3, we do not know. What we need to do? What is the sum of the digits? 1 plus 2 plus 3. 6. 6 is the divisible by 3, so whole number can be divisible by 2. That's the rule you can take. Next. What is a unit digit value though? What is a unit digit value? Unit digit value, say, for example, you can take like 1 into 2 into 3 into 4 into 5 into 6. What is a unit digit? What is a unit digit here? 1 into 2, 2. 2 into 3, 6. 6 into 4, 24. What is a unit digit? 4. 4 into 5, 20. 0 is a unit digit. Multiplied by 0, any number is 0, like 0, like that. Okay? Yes. And the remainder rule, if the number is divisible a certain number, for example, you can take now 11. 11 by 2, what is the remainder? So, any odd number is divisible by 2, the remainder is what? 1 like that. Many questions can be formed like that. Number of trailing zeros. What is the zeros will happen like that? Number of, how many zeros are possible in the product of, for example, take like 5 factorial. What is the number of zeros will happen? 5 into 4 into 3 into 2 into 1. It means what? 120 it will come. 5 into 4 into 3 into 2 into 1. So it means what is a 120 it will come. So 1 0 will happen. 10 factorial, how many zeros? And 25 factorial, how many zeros? 100 factorial, how many zeros? So there is a formula for that. We can finish it off that is it. We can check the number of 5s and number of 2s. Combination of 1, 2 and 1, 5 is equal to generating 1, 0. That is a thing. Okay. So in detail it can be discussed in the when the chapter arises like that. And n factorial and 0 factorial. Again, see here n factorial. N is a natural number. N factorial and 0 factorial. 0 factorial always equals to 1. 1 factor is also 1. 0 factorial is also 1. So these are the very basic, simplest form this is. This is the concepts this is. Properties this is. That's why we say like that. Yes, next. P square minus 1, where P greater than equal to 5, always divisible by 24. Is a fixed property. Okay, we have to write and see all these things. LCM and SCF. You will have 2 questions in every paper about LCM, 2 questions. And 2 questions will happen from SCF. LCF 2 questions and SCF 2 questions. See the 4 questions. The moment you start reading the question, you must know whether this is the LCM or SCF. Like that. Okay, now 3 plus 4 is equals to 5. This is the Pythagoras theorem. This is the Pythagoras theorem. See, for example, this is 3 and this is 4. What is this? It means this is equals to 5. Like 3 plus 4 is equal to 5 means we learned in our school days like root AB square plus root BC square is equals to root AC square. This is the formula. But we don't remember so much of big formula. We can say 3 plus 4 is equals to 5. It means 3 square. What is 3 square plus 4 square? 3 square is what? 9. Plus 4 square is what? 16. It means what? 25. And root 25 is 5. It means this is the 5. That's the very simplest form. That's where we need to save the time, where we need to practice these questions in our regular classrooms like that. Okay? Okay, more question will be followed by in upcoming classes. Let us see. And now 25 we can see that is. Now this is one 25 I think. Change the paper. Fine. So again, apart from this, the many things are there. Like this is the very number system. What I mentioned so far is what is all related to number system, where you can see 20 questions are happening from 18, ranging from 18 to 22 questions are happening here like that. Okay, and here you can see. So far, what I discussed related to 20 questions. And remaining questions, what? Logical reasoning, aptitude. What is a logical reasoning questions? In fact, I have not mentioned here. What is the regular, you can see number series, alphabet series, like letter repeating series, and alphanumeric series, like number test, ranking test, direction sense test, logical sequence of words, and like a syllogism, directions related test. So all these things will come. In the sense of aptitude, what will happen? Core subjects are what? Time and work, time and distance, and averages, percentage, profit and loss, discount related, allocation and mixture, simple interest, compound interest, permutation and combinations, probability. Next, what are the things? Okay, LCM, SCM we have discussed here, and more about the fractions, percentages. Sorry. The percentages, that is. So these are the questions generally will happen like that. You can see number system is a backbone for any CSAT aspirant than comparatively than any other exam. So 20 questions where after 20 at least you can solve, anybody can solve 14 to 15 subject to a practice with a full-fledged one, that is. Where we are finding the terminology, reading, understanding is difficult. Terminology we find difficult. So if you start learning these process, everything, and that becomes easier, people can solve that questions. Yes, and I shall wrap up this program. Where anything I could say, 3 plus 4 is equal to 5. This is the Pythagoras theorem formula. This is fine. Now we can see LCM, SCF. How to LCM, SCF also have detailed mention numbers. What is the finding LCM for the numbers? Already we know that. SCF also we know, we learnt on school days also. Decimals. If the decimals are given, how to find the LCM and SCF? For example, you can see like 0. See, for example, decimals, you can take 0.1 and 0.05. What is the LCM? So when it comes to the LCM, now first you have to convert these into the normally what? Natural numbers. To convert natural numbers, you have to equate the decimals in equal uniformity. There are how many decimals are here? 2. So 0.10, then 0.05, 5, and 10 and 5. So that is okay. And fractions are given. How to find LCM and SCF? Exponents, power, like 2 to the power of 3 and 3 to the power of 7 and 7 to the power of 11. How to find LCM and SCF? So those can be discussed in the upcoming regular classes. Okay, with a lot of details. Right. Okay. I'll wrap up the program. Thank you all. I wish you good luck, everyone. Right.